Unit 11, Day 9, using the Pythagorean identity. So from Pythagorean, you're probably thinking of the formula a squared plus b squared equals c squared, which is how you find the missing side of a right triangle. You also know that trig comes from a right triangle, so it has its own Pythagorean identity that involves the trig functions. And that main identity is sine squared of the angle plus cosine squared of the angle equals 1. And this is something you are going to need to memorize. It will not show up on your reference sheet. Probably will show up at least once on your Regents exam. But if we take a unit circle, okay, we know that a unit circle has a radius of 1. So if I draw this radius right here, it is 1. If I drop down my side, I now have a right triangle. And what we learned is that if we had a unit circle, the x value was the same as the value of the cosine, and the y value was same as the sine of the angle that's nestled up by the origin here. So if you take a look at the picture with the unit circle, and the cosine is the x horizontal value and sine is the y value, and you have a hypotenuse of 1, then using Pythagorean theorem, legs squared plus legs squared equals 1. Okay, and then they just switch sine and cosine order around because it's addition. So sine squared plus cosine squared equals 1 is a Pythagorean identity. And sometimes you will be asked to use this identity to find other trig values rather than just drawing the right triangle and doing the Pythagorean theorem. So in the next example, I'm going to show you how those two things look different, even though both of them can be used. The Regents might seriously come out and say, use the Pythagorean identity, in which case, use that or you only get 1 point. So for example 1, it says the sine of some angle is 2/3. It's in quadrant 2. Okay, so when they tell you what quadrant the angle's in, that's just to help you decide if it's positive or negative, which we will worry about at the end. So they want us to find the cosine of theta and the rest of the trig values. So the question itself was not worded in such a way that it says we have to use the identity, but they could easily change the wording and make that happen. So we're going to do it both ways. So the Pythagorean identity is that sine squared of the angle, and you can do theta or x or whichever letter symbol you want to use, sine squared plus cosine squared equals 1. So this identity will work because the information they gave me was the sine. So now what I'm going to do is I'm going to fill in the value of the sine so that I can solve for the cosine. The sine of the angle gets squared. So when I fill that in, it's going to look like 2/3 squared plus cosine squared theta equals 1. So of course the next thing I'm going to do is I'm going to square that. Now I'm going to leave it a fraction. 2 squared is 4, 3 squared is 9, plus cosine squared theta equals 1. And then I have to get cosine by itself, so I'm going to subtract 4/9. So cosine squared theta equals 1 minus 4/9 is 5/9. And then to get the cosine by itself, I'm going to square root both sides. So now I have that the cosine of my angle is equal to, now if I look at the numerator, I can't take the square root of 5, so I'm going to leave it square root of 5. But I can take the square root of my denominator. Square root of 9 is 3. So the cosine ends up being square root of 5 over 3. But before I call myself done, I got to go back and say, hey, that angle was in quadrant 2. In quadrant 2, cosine is negative, so I need to put a negative on my value of square root of 5 over 3. Okay. Now, it did say find the rest of the trig values. Okay, well, we've got the sine, we've got the cosine. We know that tangent is equal to the sine divided by the cosine. So we have 2/3 divided by negative root 5 over 3. So we can do keep, change, flip. We can type it into our calculators. I don't recommend the calculators though, because square root of 5 is an irrational number, which means your calculator is going to give you a yucky decimal, and they're probably going to say exact value on a regent. So let's do same, change, flip. Top fraction stays the same. We're going to change it to multiply, flip the second fraction, and then when we multiply, the 3's are going to cancel out, and we're going to get 2 over negative root 5. Now, it didn't say in simplest form. If it did, I'd have to rationalize that denominator, but since it didn't, I'm going to leave it right there. Okay, so we now know the sine, we know the cosine, we know the tan. There are 3 other trig values. There is the cosecant, the secant, and the cotan. Those are our reciprocal functions. Cosecant is the reciprocal of sine, so 3 over 2. Secant is the reciprocal of cosine, so negative 3 over the square root of 5. Cotan is the reciprocal of tan, so negative root 5 over 2. So there are all the rest of the trig functions. Once you know the sine and the cosine, which you can get from the identity, you can find all other trig values. Okay. That's using the identity. We said you could use the Pythagorean theorem, and you guys have done this before. So draw your crosshairs. Your angle is in quadrant 2, so I'm going to draw my angle in quadrant 2, and I'm going to make my right triangle. The sine is 2/3. Sine is opposite over hypotenuse, so opposite over hypotenuse. And now I'm going to use the Pythagorean theorem to find the missing side. So 2 squared plus b squared equals 3 squared. 4 plus b squared equals 9. Subtract the 4. B squared equals 5. So b is the square root of 5. But because you're in the second quadrant, I know length can't be negative. But when I do my trig, I'm going to put the negative on there so that I don't forget it. So now I have everything, and I just use SOHCAHTOA to get the same answers we did using the identity. So I'm not going to do it again. Okay. Now, that's the one big identity that you really need to multiply or memorize. There are 2 other identities that you can get from it. So as long as you know how to make the other identities show up, you don't have to memorize these. So if you take the Pythagorean identity of sine squared theta plus cosine squared theta equals 1, you can do anything you want to an equation as long as you do it to everybody in there. So if we divide everybody by a cosine squared, then this first term right here, sine squared over cosine squared, sine over cos is how we find tangent, so it's going to end up being tangent squared. Anything divided by itself makes a 1. And then 1 over cosine, okay, so the reciprocal of cosine is secant. So since it's a reciprocal of cosine squared, you get secant squared. And there you get another identity. Likewise, you can do the same thing by dividing everybody by a sine squared. So that first term turns into a 1. Cosine over sine is upside down for what we usually use for tan. Well, a tan that gets flipped over is a cotan, so cotan squared. And then the flip of a sine is a cosecant, so that's how we end up with cosecant squared. So if you divide everybody by cosine squared, you get the second identity. If you divide everybody by sine squared, you get the third identity. So you really only have to memorize 1. So we're going to look at example 2. The tangent is negative 3/4. And in quadrant 4, what are the rest of the trig values? Once again, we could use Pythagorean theorem, which we will do in a minute, but they'll probably tell us to use an identity. Not really sure. So using the identity, I don't memorize the second and third one. All I memorize are sine squared plus cosine squared equals 1. Now, if they're giving me a tan, then I choose what to divide everybody by in order to make sure that I get a tangent. Well, I know tan is sine divided by cosine. So if I put a cosine squared under this, I'm going to get my tan. So I'm dividing everybody by cosine squared. And that's how I decide whether I'm dividing by cosine or sine. So this turns into a tan square. Cosine divided by itself is 1. And the reciprocal of cosine is secant, secant. So this is going to be a secant squared. Now that I have come up with the identity, I can fill the tan in. Tan is negative 3/4, so I have a negative 3/4 squared plus 1 equals the secant squared. Well, let's see, that's going to be square the negative 3 and I get a 9, square the 4 I get a 16. 1 is equal to 16 over 16. Add the numerators, I get 25/16 is secant squared. And then when I square root both sides, the secant square root of 25 is 5, square root of 16 is 4. Don't forget when you're done, you need to go see what quadrant you're in. I am in quadrant 4. Secant is the reciprocal of cosine. Cosine in quadrant 4 is positive, therefore the secant will be positive, and this is done. Now it said find the rest of them. Alright, well, right away I'm going to say then the cosine is equal to 4 over 5, because I can flip that one. The tangent we've got, so cotan would have to be the flip of tan, so negative 4/3. Sine and cosecant are the ones that we're missing. Well, tangent is equal to sine divided by cosine. So my tan is negative 3/4. My sine is what I'm looking for. My cosine is 4/5. So if I multiply both sides by 4/5, I'll know what my sine is. Okay, so I'm multiplying these guys right here. My 4's are going to cancel out, and that's going to leave my sine to be negative 3/5, which makes my cosecant negative 5/3 when I flip it. So there are all your trig values. Probably thinking that the identities are going to be a bit harder and longer than Pythagorean theorem, and I won't disagree with you. Like I said, they might force you to use the identity on the regents. They might say use the Pythagorean theorem. They just might say find it, in which case you have your choice. This way you know both. Alright, so Pythagorean theorem says I'm in quadrant 4. So here's my angle. Make a triangle. Tan is opposite over adjacent. So we know that's a 3, 4, 5 right triangle. And bam, SOHCAHTOA will get you all your trig functions. So sine is negative 3/5. Cosine is 4/5. Tangent we already had. And then flip them over. And yes, Pythagorean theorem is faster and shorter. But you need to know the identities. We do other things with identities too, but it's such a complicated topic that that's something that we will do when you are actually in class with somebody explaining it to you. So day 9 is the homework that goes with this. The instructions say use the identities. Good luck.